Hello, welcome. Today let's try to solve another Leetcode problem, 2258, escape the spreading fire. So it is a lot of description, but let me explain the question first. After that, I will start coding. So while I'm coding, I will still explain each line of my code. Definitely this is gonna be a hard problem. Yeah, I think this is gonna be a medium hard problem. Yeah, this means this problem can be solved, but you might make a lot of mistakes because there's a lot of coding. But it's not some kind of a problem that you can never understand. Yeah, if you understand the basics of BFS and you understand the basic of binary search with guess and answer, basically you can find a solution to solve it. But the coding is a lot. You have to find a way of coding it up. Now let me make a drawing. Oh, the drawing is not here, but let me make a little bit of drawing about this one, because this problem gonna be take a little bit time for the coding. So I think I need to make a little bit drawing to explain it. Otherwise it's gonna be really difficult to understand. So there will be several cases for this problem. So in some cases, so in this first example, the person at the top left corner, and the person will go to the bottom right corner. If the fire spread and with the person go, if the fire goes just before the person and this person can reach the house, it means it is a success. It is safe. But we just need to check the stay time. So for example, the stay time is 3. It means the person will stay here for 3 minutes and the fire will go somewhere. For example, the fire goes here at this position, but the person can go here, the fire can go here. Let me just make a drawing like this. So for example, the person will be wait at this position for 3 minutes, and until 3 minutes the fire may go at this position, just one position before him. Then the person goes here and the fire will be here, the person will be here. And it will be continued like that until the person reaches the house. So this is a success and the waiting time is 3 minutes. And for some situations like this way, so there is always be a wall. Even there is fire at this position, but this is the wall and this is just a safe place, so the person can directly go to the house. So it means this person don't need to wait for the fire spreading, just need to go to the house directly. So we're gonna return 10 to the power of 9. So for this testing case, so in some cases in this example, the person cannot go to the house. In order to go to the house, the person cannot go this way. Maybe the person goes that way. If the person goes this way, the fire will catch up with him. So the description said if the fire catch up with the person, but the person is not at the house, so we're gonna return a false. So it's gonna be -1. But if the person reaches at the house, this person, the fire also reach at this position, we're gonna return a true, because this is what the description said, as you can see from here. Note that even if the fire spreads to the safe house immediately after you have reached it, so immediately I reached it, and the fire immediately comes here at the same position, but I'm gonna return a true. It will be counted as safely reaching the safe house. So I reach it, and then the fire immediately reach it, so it's gonna still be a safe. So these 3 examples is very helpful for us to understanding the question. Now let's try to find a way to solve it. To solve it, I think the easiest way we can use a binary search to guess it. So for example, this is 3 minutes in this case. If we guess this person gonna stay 3 minutes. If the person gonna stay 3 minutes, so it means at the first position, top left corner, at this position, the person already have a time. This time is 3 minutes. But is there fire in this place, we don't know. But we can use a BFS to check the position at each of the position inside the grid for the fire reaches. So for example, yeah, let me make it easily. So if the fire at this position, so this is a fire, yeah. So at this position, I'm gonna use a 0. It means at time 0, the fire will be at this position. But at time 1, the fire will be at this position. And this is 1, 1. This is 2, yeah, because this is 1. And this is also 1, 1. And this is 2, right? Yeah. So it means I can use a BFS to get the time for the fire when the fire reaches at each position inside the grid. And this gonna be 2, and here gonna be 3, and yeah, this one gonna be 3. So it means the fire spread to this position, it's gonna take 3 minutes, and here 2 minutes, and here is just 1 minute. Yeah, if there are multiple fires, it doesn't matter, because the fire will spread at the same time. So this will be a multi-source BFS. Yeah, I think for the multi-source BFS, it's gonna be easy to solve this kind of problem. After reusing the multi-source BFS, we can get a grid for the fire time. It means the fire will reach each position. Yeah, it will be the time for the fire reach at each position. So while I'm drawing it like that, if we get a time like this, so basically we can compare with it. So for example, this person at this place, if we get a stay time of 3, so here the person at here is 3, but this time is 3, it means it is not possible because the fire has already reached at this position. But what if the fire is just 2? It means this 3, yeah, 2 is not possible. What about this is 4? So if the fire reaches this position at time 4, but while I'm staying at this position, the person will be started to go at 3. Yeah, at 3 the person stays here, but at 4 the person will go out. It will be here. Yeah, the person will go out at time 4. Yeah, but here the fire will reach here at time 4. It means it is safe. Yeah, so in this way we can compare with the time. Yeah, if this kind of the time for the person, yeah, if it is if it is less than, if it is less than the fire reach time, for example, the fire reach time is 4, but the person staying at this position, it means we can spread the BFS. So for the person go to the different route, it will be a single source BFS. Yeah. And basically this single source BFS will inside the binary search function. So basically we need 2 BFS. First of all, we're gonna use a multi-source BFS to get the fire time. It means the time when the fire reaches each of the position. At another BFS, it's gonna be a single BFS. Basically, we're gonna check if this person can reach the end. Yeah. Now let me continue the coding, and while there, while we found some issues, maybe I need to check the source code, or maybe I just need to explain it from here. Yeah. Basically, we need a BFS, but for the multi-source BFS, yeah, let me put it here. We're gonna need a multi-source BFS and a single source BFS. The single source BFS is just for the person, and the multi-source BFS is just for the fire, and this is for the person. Now we need a binary search. So the binary search will just search the result. Yeah. So let me start with the binary search. So for the binary search, I need L and R, and the result. This is gonna be my template. So L would be starting from let me check. So yeah, if it is not possible, it means the person cannot reach the house, I'm gonna return a -1. So for the L, I'm gonna set let me check. For the L, I'm gonna set minus 1, and yeah, for the L for the L, I'm gonna set as 0. It means the 0 minute I need. Yeah, because this means I don't need to wait. And the R gonna be R times C. And later on, I will define the R and C. And the result would be minus 1. So this minus 1 means it is not possible. It means it is not possible. Definitely, while we are executing the binary search, yeah. So the result will not be inside it. If we will not update the result will be minus 1. So the maximum of the result can be R times C. Yeah. So this means for some situations, the maximum can be for example, the person is here, maybe the fire is some other places, and the person can wait until a lot of time, but the maximum is R times C. It cannot be R times C, but we will set a maximum. This will be easier, because for the different testing cases it will be different, but the maximum R times C would be safe. Actually it should be less than R times C, but we're gonna use this R times C to check the result. Let me prepare this R and C. So R and C would be length of the grid and the length of the grid 0. So I'm gonna use the binary search template while L less than or equal to R M. I'm gonna use M. So M would be equal to L plus R minus L divided by 2. I'm gonna check this M. I will write this check function later because this check function is basically a single BFS. I will write it here. So here will be a check function, and inside I will take a stay time. Now, if this is possible, so I'm going to record the result would be equal to M. And if this time is possible, but I want to have the maximum time, so the L pointer would be equal to M plus 1, because I need to have the maximum time. So the lower boundary should be equal to M minus 1. Else, the higher boundary R should be equal to M minus 1. Finally, I need to return this result. If result less than R times C, else I'm gonna return 10 to the power of 9. So here this means if I can find a result, this result is less than R times C. It can be minus 1. Minus 1 means this result is just not possible. Or it can be 0 to R times C. But it should be less than R times C. If it is equal to R times C, because this result, the maximum value can equal to R times C. If it is equal, it means for each of the time, it is always valid. This check function is always valid. It is like this case, this testing case. So I'm gonna return 10 to the power of 9. If it is not like that, I will return a value below R times C. Because normally the result can never be R times C. If it is the result is R times C, what does it mean? It means this check function is always valid, and the L boundary is always bigger, and the result is always bigger. But there is the maximum. It's gonna be R times C. So this is why, I'm gonna write it like that. Now, I'm gonna, try to prepare the fire time. So the fire time is just needed to record the fire when the fire is spreading at each position. So I'm gonna prepare a directions array. So this direction is just the 4 directions: 0, 1, 0, minus 1, 1, 0, and minus 1, 0. Now I'm gonna execute this BFS. I'm gonna call this BFS because here this is gonna be the multi-source BFS. Yeah, but before that I'm gonna have a record. So the record will be the fire time. So this fire time will be yeah, a 2D array. So before I gonna set it to infinity because I will use this infinity to check the smallest value. Yeah, and this infinity, yeah, you can check, you can set it as other values. It doesn't matter. I think infinity is just okay. So times here gonna be C. So for r in range, we just copy a DP array, but inside the values should be infinity, and r in range r. Yeah, basically I'm gonna record the fire time at each of the positions. After the BFS, I'm gonna record this time. Yeah. Now I'm going to write this BFS. So for the BFS, it is just a multi-source BFS. We're gonna put all the fires. Yeah, we're gonna put all the fires inside the queue. So I'm gonna prepare a queue would be the queue, and inside yeah. So yeah, I'm going to prepare an empty queue because I need to put the positions inside. So basically I need to check it. Yeah, so I have to check the fire. Yeah, let me yeah, let me check the fire. So for r in range, r, and for C in range C, I want to check the fire if this grade RC equal to 1, because 1 is the fire. I need to put it inside the queue. I want to also put the time inside the queue. So queue.append, I need to put this R and C with 0, because from the beginning, for example, this position, for the fire reach this position, it's gonna be 0, and then the fire will spreading, and it will spread except the walls. Yeah, it can also reach this person. Yeah, because the person is not walls. As you can see, it is a 0, it is just grass, so it will spread everywhere except the walls. And it can also spread to the house. Yeah, as you can see that, just except the wall. Yeah, so this is the preparation for the multi-source BFS. It means everything will be RC and 0, 0 is the time, everything will be just inside the queue. Yeah, now we just need to finish the BFS part for this multi-source BFS. So yeah, while queue, we will pop it out. So for RC and T for time, RC is for position should be equal to q.pop left. Now I'm gonna write the multi-source BFS template. Yeah, basically it is just a BFS template. So I need to check the directions. Yeah, because there are 4 directions for the fire spreading. So for DRDC in directions, my row and column should be equal to R plus DR and C plus DC. Now I'm going to check the boundary. So if this row more than or equal to 0, less than R, and similarly for the column, yeah, and less than C. I also need to check, because here I didn't prepare the visited set. Yeah, because I can use this fire time as my visited set to check. If inside the value is infinity, it means I didn't visit it before. Yeah, otherwise I can set it a value. So, and I also need to check if it should not be a wall. So if this grid row and column not equal to 2, yeah, because for 0 1s it is always possible, it means I can reach. But for this 2, definitely it is a wall, I cannot reach it. Yeah, so I have to check if it is not a war, and I also need to check the visited set. Here I'm gonna use this fire time. Yeah, and this fire time. Yeah, because I want to update it. Row and column equal to infinity. Yeah, if it is infinity, it means I didn't visit it before. Now I want to visit it. Basically, I'm gonna put a value instead of infinity. It's gonna be 0, 1, or 2. It's gonna be 1, 2, or 3. Yeah, like that. So the queue should append the result. It's gonna be the row and column. Here gonna be t plus 1, because from the beginning the time is 0, and after I go to the next position spreading, the time will be plus 1. Yeah. So after executing this BFS, basically I'm gonna update my time. Yeah. But how to update it? So the fire time would be updated from here. Row and column would be equal to t plus 1. So after executing this multi-source BFS, basically the time will be updated. Now I have a fire timer to the array. Yeah, so this means I can use the check function, the single source BFS, to check my result. Yeah, the single source BFS would be similar like the multi-source. Yeah, just we don't need to prepare this kind of things, but basically it's gonna be the same. Yeah, now let me prepare the single source BFS. So I'm gonna have a queue, but inside the queue I'm gonna have the positions, because the person will be at 0, 0, and the state time. Yeah, the state time is given by the binary search, because in binary search we have this m. This m basically is the state time. Yeah, because from the beginning we're gonna put the state time inside. Yeah. Now we're gonna write this single source BFS. Yeah, let me just finish writing. For this single source BFS, because I cannot use this fire time, because this fire time has already set the values, except the infinity. For example, at the worst it may be infinity, because the fire can never reach. Yeah, so this means I cannot use it. So I would use a weighted set as the single source BFS. So the weighted set would be equal to a set. So inside it's gonna be 0, 0, because the person is staying at this position. Yeah, so this basically means that the person can never go back. So I need a weighted set. Now I'm going to check the queue. So while queue, I'm gonna pop out similarly. It's gonna be RC and T should be equal to q dot pop left. Yeah. Now let me copy the code, because it's gonna be the same from here. Yeah. So after I pop it out, I'm gonna check the directions, and I'm gonna check the boundary. So I'm copy all this code and change a little bit from here. Yeah, because you should know that the single source BFS or the multi-source, basically they are the same, so I can copy the same code. So here we need to check. So this row and column would be equal to R plus DR and C plus DC. Now I need to check the boundary. And I also need to check if it is not war, because the person can never go to the war. So if it is not war, but I don't need to check the fire time array, because it doesn't matter. Yeah, because I just need to check the person, because the person can't go to the fire time array. Yeah, can go to the fire positions. So yeah, so let me check. So if it is not equal to 2, yeah, I have to check the person is not inside the weighted set. So the row and column should not in the weighted set. Yeah, if it is not inside, basically I can do something. Yeah, but before that I need to, yeah, so here it would be the difficult part. So if the person and fire stay at the same position, for example at here, definitely I'm gonna return a false. But if the person and fire reach this position, I mean the house position at the same time, I'm gonna return a true. So this is why I need to check it from here. Yeah. Now I need to check the time. So basically I have a fire time array. Oh, why not? There is not. Oh. So if the fire time array row and column, yeah, let me yeah, if this fire time is less than the t plus 1, because from the beginning I'm at t, but while I'm reaching the 4 directions, any of the directions, the t would be plus 1. So if this time, yeah, let me check if it is less than or more than. For example, this is 3 and this is 5. Yeah, it should be more than. Yeah, it means the fire will reach here, for example, in 5 minutes, but here t plus 1 is just 4. It means the person is safe. Yeah, so we can put it inside the queue. Yeah, so if it is like that, but for this if check, it is except the last position, the house position. If it is not at the house position, I can use this condition to check. Yeah. So my queue should append the result. So it's gonna be row and column and t plus 1. And similarly, the visit should be and the row and column. Yeah. But what if the person stays at this position? We need to check the result. Yeah. So this means before that we need to check the result just here. So if this row and column, row equal to r minus 1 and column equal to c minus 1, so this basically means the person already reached at this position. If the person reaches position, we need to check the result if it is a true or false. So we can just use this fire time with t plus 1 to check. Yeah. So the fire time should be more than and equal to t plus 1. So for example, the fire time is 5 and t plus 1 is 4, it is okay. If the fire time is 5 and t plus 1 is also 5, it is still okay. But if the fire time is 4, this person, the t plus 1 is 5, it means it is not okay, because at the time 4, it is already on fire. But at the time 5, the person can reach this house. Definitely it's gonna be wrong. Yeah. So for here, we can return a true or false. But it can be also like that. Yeah, but it can be also like yeah, let me check. But it can be also like this case. Yeah, it means no matter how much time waited, even it is 0 time waited, the person can never reach the house. Yeah. So if we didn't execute the BFS, so we're gonna return a false. Yeah, this false just means this person cannot reach the house. So for example, this is a wall, this is a wall, and this is also the wall. The person can never reach the house, even there's no fire. There's always walls. We're gonna return a false. Yeah. If it is always a if it is always a false, we will not execute the check function. It means this value will be smaller and smaller. Yeah, I think here would be safe to be -1, but let's check. Yeah, and the result would be -1. If it never execute, yeah, this 0 is also okay, because if the check function never execute, it means this person can never reach the house, even without fire, because there's always walls, obstacles stopped the person going to the house. So the check function will never execute, and this value will be smaller and smaller, but the result will be still would be -1. Yeah, as you can see, a lot of coding, and it might be produce a lot of mistakes like typo and any kind of other mistakes we have to check. Yeah, this fire, it should be fire time if I remember right. Now let me try to submit it. Yeah, as you can see, it works, and this is basically checking how are you good at using BFS. If you are really good at using BFS, you will not make a lot of mistakes. Basically, after you learn for one time, after that time, you might write the right code. The difficult part, I think, is about this area. You have to check from here, or otherwise, you can also put this row and column inside the queue, and you check from here. It's gonna still be the same. Now let me just submit it. As you can see, it works and it's pretty fast. And now let's analyze the time complexity. So the time complexity would be m times n times log m times n. Because for this kind of a BFS, it is just m times n. We didn't do anything. It is just the BFS. And for this type of BFS, it is m times n. But for here, we have a binary search. Inside the binary search, we have the BFS. So that is why it is m times n, log m times n. And let's check the m and n. M times n is 2 to the power of 4, so that is why it is so fast. Yeah. As I explained earlier, if you don't know how to write it like this, maybe you want to put it inside the queue, you have to check from here. So for example, you have to check if r equal to r minus 1 and c equal to c minus 1. Yeah, it means you've already reached at this position. Basically, the time already meets the conditions. You're gonna return a true. Otherwise, finally, you're gonna return a false. You can also write it like that, but here you have to change a little bit. Yeah. So for here, if this is row equal and column equal, and you have to check this fire time. Yeah. So you have to check if this fire time is more than and equal to t plus 1. You have to copy the same code. Yeah. So this just means you just write more lines of code, but basically it's the same. Yeah. So if you reached at this position, and also you meet the time conditions, the fire time is more than equal. Basically, you can put it inside. If you put the row and column inside, so for the next loop of the BFS, you're gonna find it out. If you find it, you're gonna just return true. If you didn't find it, it means basically you didn't execute this kind of if check. You're gonna return false. If you find it, you're gonna return true. Now let me run it to check. Yeah, as you can see, it also works. But maybe, yeah, you would rather write this kind of a function. You're gonna return it from here instead of here. But it's the same. Yeah. Yeah. Now let me summarize a little bit before the end of this video. This is a difficult problem. It is 23,000 for the readings. For the readings, even for the BFS, it is a hard problem. But this problem is really difficult to think about the different conditions. So at which condition you're gonna return a minus 1 or 10 to the power of 9, you have to check the different testing cases. And a lot of edge cases you have to consider, like here. Why you have to check the result if it is less than r times c. Otherwise, if it can reach r times c, it means the check function is always valid. You don't need to stay, and you can even stay infinite time. Basically, you're gonna return this one. Yeah. Thank you for watching. See you next time.